let's start. We're talking about inverse functions today. Now, I've mentioned inverse functions to you guys very briefly in methods. In methods, when we're talking about e to the x and ln of x, they are the inverse of one another. Okay, if you remember, they are symmetrical about the line y equals x. Okay, that they're like a mirror image of each other about that line. That's what we're talking about when we say inverse function. So, for a function to have an inverse, it has to pass two tests. All right, it has to pass the vertical line test, which we remember from year 11. Okay, the vertical line test is what separates a relation from a function. Okay, so a relation is any link between two variables, x and y. A function is a special type of relation where each x value has one unique y value. That's what a function is. And we denote that by f of x, a function with regards to x. Okay, so that means it's a function. So if we were to perform the vertical line test, we would see that this is a function. Okay, because each x value, or each line only cuts the function once. Each x value has one y value. The same with this one. Okay, it passes the vertical line test, so it's a function. But this one does not. Okay, see here it crosses it twice, crosses the curve twice. That means it's a relation. All right. So that's how we discriminate between a function and a relation. But next we have a special type of function. Okay, that has an inverse. Okay, and it's going to have an inverse if it passes both the vertical line test and the horizontal line test, which is where we just draw lines horizontally. Okay, and so it's the same test. It has to cross the curve only once. Okay, if it crosses the curve twice, so this passes the vertical and the horizontal line test. This function will have an inverse. This one over here, it passes the vertical, but it doesn't pass the horizontal. Okay, and we have a special word for this type of function. So it has an inverse. We call it a one-to-one. All right. What that means is each x value has a unique y value, and each y value has a unique x value. Okay. Whereas over here, when it has more, when each y value, you can see each y value has two values of x. We call that many to one. Okay, and relations. All right, so let's get into the first example. Just wondering if there's anything else I need to read there to you guys. By the notation, so we use f of minus 1 of x to denote the inverse function of f of x. Okay, that's what f of minus 1 of x means. And then just consider those three dot points there. It's a reflection about the line. So we're going to get into what they look like in a step. But we've got the domain of the inverse is equal to the range of the function. And the range of the inverse is equal to the domain of the function. And that'll become clear when we graph them as well. And then there's a little bit there about self-inverse functions. They may pop up in the textbook. When they do, just refer to the notes here. Okay, so here's our first function. Can we please change it to a plus, by the way? I understand it's a negative, but I think if we change it to a plus, it's going to allow us to demonstrate it a bit better. So firstly, we're going to sketch this graph, and I'm just going to unpack how we should think about this kind of thing. Okay, what the 2 means is half, isn't it? It's half times 3 plus 4x. And looking at that can be a bit confusing for some people to see that it's the equation of a line. Okay, but it is. It's just the equation of a line. And so let's express it as so. It's 3 on 2 plus 2x. All right, that's what f of x is. Okay, so we've intentionally set it up to make you think about what is this type of function. It's the equation of a line. It has a y-intercept of 3 on 2. That's 1.5. And it has a slope of 2. So let's sketch it. I'm going to sketch it in red. So a y-intercept of 1.5. All right, so that's where its y-intercept is, and a slope of 2. That means as x goes across 1, it goes up 2 units. Okay, so it's going up from 1.5 to 3.5. Okay, and you can sketch a few more points there, but that's enough for us to sketch this. I might do one more. So if we go down 2 from 1.5, that'll be to half, and across 1, this point here. All right, and so I might just sketch this line through those points as best as I can. Yours is going to look better because you've got a grid. this is f of x. All right, nothing outrageous there. We're just sketching the equation of a line. And the dotted line there, that's the equation of the line y equals x. Okay, for you it's dotted. There we go. Now we're going to sketch the inverse. All right, so you could just try to go, all right, so I've got to picture it flipped like that. Okay, it's flipped over, and so it's going to be going from here down that way kind of thing. All right, but let's get it right. Let's think about it. Let's look specifically at the red line. Okay, it passes through. Firstly, that's where it crosses the line. So our blue line is going to pass through that point. Okay, our blue line is going to pass through that point. And up here, the coordinate is x is 0, y is 3 on 2. All right, so what that means, that's very useful, because what that means for our inverse function is that it's going to pass through x is 3 on 2, y is 0, that they swap. The x and y values swap with one another. So that means we're going to have x is 3 on 2, where's that here? 1.5, 3 on 2, and y is 0. All right, and now I've got a couple of points that I can sketch that line through. I might do one more. This coordinate here is, let's talk about that coordinate. That is, x is 1, y is 7 on 2, or 3.5. Let's think that that's 3.5. Which means it's going to pass through. The other coordinate it will pass through, they just swap. X is 3.5, and y is 1. So 3.5 is here, and 1 here. Okay, now I've got enough points to sketch that line through, roughly. Okay, yours is going to look better because it's on grid. And so we have f of x, and we have the inverse of f of x, f of minus 1 of x. All right, and you can see that they're symmetrical about the line y equals x. All right, now I'm just going to clear away my scribbling at the top here for our next working out part. Okay, now we're asked to find the equation of f of minus 1 of x. All right, first using coordinate geometry. Okay, we've grabbed these two coordinates. We know that they lie on the inverse function. Okay, how do we get them? Well, these ones are on f of x, and so when we swap them, they lie on the inverse, and we can use those two coordinates to find the equation of a line. Simple, let's do that. We first need the slope. All right, so if we have y2 take y1, so it's going to be 0 take 1 on 3.5 take 1.5 on x2 take x1. I've got them around the wrong way. 0.5 take 3.5. 1.5. Why is that 3? 3 on 2 is 1.5. Alright, so x 1.5 and 3.5, y 0 and 1. That's how I'm getting these coordinates. Okay, to process this, we're going to have 0 take 1 is minus 1, on 1.5 take 3.5 is minus 2. That simplifies to half. Okay, and the slope is half. And it is a positive slope because we can see it's increasing. As x increases, y increases. Alright, so we've got the slope of the line. And then we know from the equation of a line, it is y equals mx plus c. We have a slope of half. Alright, and you might be able to see the y-intercept very clearly. My scale's a bit off, so I'm not going to guess it. I am going to work it out. We've got it, we don't have it listed here. So we'll work it out. We've got when plus c, and we'll go when x is 3 on 2, y equals 0. When x is 3 on 2, y is 0, so we'll plug that information in. Okay, so just as well I didn't, because it looks like half to me. So we've got c is minus 3 on 4. So the equation of the inverse, let's denote it properly, is f minus 1 of x equals half x take 3 on 4. so that's how we can use it just using the coordinates. We know it's the equation of the line. We know how to find the equation of the line. All right, any questions about that one? Excellent, okay. So the next part's probably going to be the predominant method that we use for finding the inverse. All right, and this is called variable interchange. And so the equation, I want to make a little bit more space. I might go come over here and then I'll run it out in a sec. So the equation of the line, right, is y equals 3 plus 4x on 2. That's the equation of f of x. All right, so if we want to find the inverse, what we're going to do is swap x with y. Okay, so I'm going to restate what I have there, but I'm going to restate it like this. X equals 3 plus 4y on 2. All right, so I've just restated it, but with swapping the x and the y around, just relabel them. And then all we have to do is solve for y. We want to get y by itself. So we'll have 2x equals 3 plus 4y. We'll have 4y equals 2x take 3. And we'll have y equals 2x take 3 on 4. Which is, half x take 3 on 4. Okay, so that way's a little fair bit easier, fair bit faster. Okay, any questions about the variable interchange? That's the second procedure. All right, and in this exercise, we're going to be required to do a little bit of both. Okay. Question 2. On the graphs, sketch the inverse. Okay, sketch the inverse. So we're just going to try and, it doesn't need to be exact, but we're just going to try and get it as good as we possibly can. All right, so it's helpful to think about the coordinates, right? And list them if you need to. So here we have x is 0, y is minus 2. So that means on the inverse function, it's going to be x is minus 2, y is 0. Wherever f of x crosses this line, okay, the inverse function will do so also. All right, wherever it crosses the inverse, so will f minus 1 x. So we've got enough points there to sketch a line through there. All right, just a rough sketch, f minus 1. I'll go back to the red. Okay, same here, we've got 0 and minus 2. So that means this is going to be the point, minus 2 and 0. That's where it's going to start. And we've also got like 1.5 roughly, okay? 1.5, 0. So that means it's going to be up here somewhere as well. Okay, it's going through those points. And let's put in the line, you've probably got it sketched there as well. I don't, so I'm going to sketch it in. Let's sketch the line y equals x. All right, so they're both going to cross at that point. All right, where it crosses the line y equals x, that's where both of them will cross together. So it's going like, it's going to be pretty bad, but like this. Okay, that is f minus 1. Okay. Now with C, the third example, we've got a y-intercept of minus 1 on f of x. That means the x-intercept of 1 on f of x. Okay, that's where it's crossing the x-axis. They're both crossing at that point. All right, because that's where it crosses the line. And we can see we've got a asymptote to the positive x-axis, which means that's going to be an asymptote on the positive y-axis. So it's going like this, it's asymptotic here, it passes through that point, and then shoots down that. Okay, symmetric about the line y equals x. Okay. Might spin this board around for our next one. We've got f of x equals sine x. Part A, explain why this does not have an inverse function. Okay? Now this kind of question pops up a fair bit in exams, right? So explain why it doesn't have an inverse, and there's just one answer that we need to give. Let's think about the graph of sine x. Okay, it goes like this, doesn't it? Alright? So it passes the vertical line test, so it's a function, but it doesn't pass the horizontal line test. So therefore, it does not have an inverse. Okay? And so for part A, explain why this does not have an inverse function. When you're required to explain, all you need to say is sin x does not have inverse because it is many to 1. Okay, so that means although each x value has a unique y value, each y value has multiple values of x. Alright, it's many to 1. You could also write another way to describe it, it fails horizontal line test. Fails horizontal line test. That's the justification for why it's many to 1. Okay, so that's part A. Part B, consider the function from 0 to pi on 2. So now they're going, now let's just localize and restrict the domain of the function. Okay, so for sine from 0 to pi on 2, all right, I'll go to there, it's just positive. It's going up, and then there's a peak, and then it's going to go down. All right, it's just positive. That's the graph of sine x for pi on 2, 0 to pi on 2. Explain why this now has an inverse. Why does this have an inverse? Okay. Sin x, so B part 1, sorry. Sin x for 0 less than x less than pi on 2 is 1 to 1. Right. Over this interval, it passes both the vertical line test and the horizontal line test. Okay, part 2, sketch the graph of f of x and f of minus 1 of x. Now, what we're going to do, so let's pull out your graph, okay, and because we're sketching an inverse from x is 0 to pi on 2, we're going to restrict our view, we go 0 to pi on 2 on the x-axis, and 0 to pi on 2 on the y-axis. Okay, we're going to sketch it over there. Now I want you to sketch, we're going to make sure it's in radians, you're going to sketch the graph of sin x, and sketch the graph of y equals x, so that we get the, we can see the line about which is symmetrical. Okay? Now, it's going to look, you guys sketch it, but it's sort of looking more like that. Okay, so there's the function. All right, and that's what we should be able to do that. And you can sketch the inverse by looking at it, but there's another procedure we can use, which is cool. Just borrow yours for a second. Okay, so what we press is, there's 2 buttons you need to press. So hopefully you've got a graph looking like mine and Flynn's. Okay, you press sketch, F4, and you'll see inverse. And it'll pop up. You need to select the function you want to sketch the inverse of. We want the function that's flashing. All right, that's the one that means you've selected. And then it'll show you, it goes like this. And you can get, I'll use a different color. You can get the coordinates from the grid on the background, but roughly like this. Okay. So, inverse functions. This is like new, but it's not overly challenging, all right? It's not particularly hard, but it is new. It's a new way of thinking about functions. So it's going to start off pretty easy, and there's lots of questions in this exercise. So we probably will spend 2 lessons on it, right? We'll probably spend today, and then tomorrow, if you look at the next exercise, I think there's 1 question. Okay, so we'll probably go over that tomorrow as well, but we'll have most of the lesson to work on this. Okay, so let's get into 3B.